Hey everybody, good evening. Here we are in week 4 of the Joy of Coding. Um, I'm looking forward to this week. This is going to be a pretty cool week that we're doing. That we've got some stuff going on here. So I kind of think about tonight and Wednesday as like a little detour through like concepts in software engineering. So not so much like Java coding and stuff. There will be though a lot, but really looking at some. Some more general concepts. So tonight we're going to talk about refactoring. And refactoring is all about making your code better for the developer. It's actually not meant to change anything for the user. It's all about making the code easier to work with. And so we've got an activity which I think is really effective. I hope you enjoy it too. That will allow us to experiment and learn about refactoring and also the tools that IntelliJ has for it. And then on Wednesday, we're going to be talking about continuous integration. And so then continuous integration is all about giving you feedback on your code by triggering like an official build of your code as you check in your code. And that'll be cool. And so we'll talk about that for a little bit on Wednesday, but then we'll do our second pair programming activity. And it's just a reminder that pair programming can be done here in the classroom. It's going to be super hot. There's air conditioning in here. And so it might be worth coming to campus just for that. Or you can do it remotely and experience a remote pairing. You can do either. Although for a couple of you that weren't able to make class Wednesday because of last minute problems, I do ask that you come to class if at all possible to experience pair programming. If you're going to do it once, it ought to be in person. I think you'll learn a lot more about it if you do. So anyway, so got some cool stuff coming up this week. Before we dive into the refactoring, though, I wanted to open up for Prime Minister's questions. Want to see how things are going. Let's see here. Everybody's gotten feedback on their koans by now, and people. Let's see. I've seen a couple of submissions for Project One. I know a lot of people are still in progress and finishing off. Anything I can tell you about Project One, though? Anybody finding anything that's confusing or like a little clarification on anything? Yeah.
I did put a question in the Slack, but for submitting it,
yeah.
Submitting it like submit.sh project one or
Submit.sh capital P project one or
capital P project.
Yeah.
I wasn't sure because the colons it was also the same name as the directory.
That is true. In this case, it is not because you'll use that same directory for projects 1, 2, and 3.
Okay.
Yep. No, excellent question.
And if we created, because I created like a separate class for like the class,
yep.
That also get collected.
Yes. Anything underneath. Oh, this is all laid out. I think the details are on in the README for the getting started. Actually, let me check that out though. Getting started. Submit. Yeah. Has submit my projects. Yeah, it talks about all sorts of good stuff here. Oh yeah. So like source files under the SRC directory are submitted, but only supports .java.xml and .txt. So don't put anything there. And then it will submit your README. Oh, although something to note. So if you're going to put your README under your resources directory, that's fine. However, if you're going to load the README from a file, you must use the resources API instead of just like the file API and the file reader. Because if you just use the file, API and you give it like a file name that's relative to like source main classes, it's not going to work when I grade it because I don't run the program in the same directory as the source code, so it won't be able to find that. So again, if you load the README as a resource, or if you load it from a resource file, then please be sure to use the resources API for it. Yep. So there's more details here. Yeah. Well, and you know what? It's like a long time ago. I used to have like one of those PDFs for submitting, and then it got long, and I'm just like, well, I should just put it here in the README. But I think it's a valid piece of feedback to say, hey, listen, the information is distributed in various places. Yeah, that's great. Yeah. Good. You shouldn't use you shouldn't use file reader because again, yeah, and this is subtle, but resources should be read as resources using the like the class dot get resource, which returns the input stream, and then you can wrap a reader around that, like a buffered reader or something, like the example in the unit test. Yeah. So actually, let me go look at that. Let's see here. It won't be in the cause repository. It'll be in the. Open it up. It'll be in the joy of coding. Yeah, let's just walk through this because I think this is something that's really important. Okay, so here I've got my README and it's in my resources directory, my source main resources. And the way I load it is that the example is in here in project 1 test. Is I use code like this. Let me make it a little bit bigger. Okay. Yeah, I use the get resource as stream. And the reason that you want to use this is because this is the following. This code is portable. So it is not, you're not reading a file relative to where the program is run, which when you create like a new file object, that's what you do. You give it a file path that's relative, it's absolute to the root file system, which you can't do. Well, you don't know where your code's going to be run. So the whole idea is that you load it as a resource, and because the readme.txt is contained in the jar file that is built, so maybe that's something important for me to show here. So if we go to, let's go here, and then I'll go back to, let's see here, David Whitlock, Joy of Coding, summer 2025. And if I go to the appointment book directory, let's see here, do I have the jar file? Oops. Appointment book, yep, .jar. Great. So if I go and I look at this using jar tf, this will display the contents, the table of contents of the jar file. We've got all the class files, and they're all in there. And then we've got, I don't know, like some things with the POM and everything. But then if we go and, we look for the README file is there also. And so when you invoke the get resources stream API, what it actually does is it goes and looks in the jar file for a file called readme.txt that's in the same directory as the project 1 class. And so here we got project 1 sort of in the same directory, then you have README. So that's how it works underneath the covers, and this is all covered in the Java I/O lecture. We'll start in the Java I/O lecture. So if you want to see more details there. But I think what you need to know is that if you're going to use the readme.txt, please load it as a resource. And then also note for project 2, there's actually a section of the assignment that talks about the fact that you shouldn't load the text file provided by the user on the command line as a resource. But that's for project 2. Yeah. Yeah, okay. Then just use the file API. Yep. So no, I'm glad you asked, because this is a subtle difference that is tricky, because it's probably, you're not used to using these APIs, and but this is something that I think is important to learn, is the distinction between a resource that is loaded as part of the application from the jar file versus a file which is passed into the program, it's input into the program by the user. So yeah, as you'll recall, in project 2, there is a dash text file, and this actually reads a file that the user provides on the file system, not a resource that's included in the jar. And so then down here, yeah, I have this note here that basically says, README, and there's so there's the README file, it should be loaded as a resource. And there's also, you'll see some examples in the text parser unit test that also read test files as a resource. Those are for your unit tests. But when it comes to the files that are provided by the user, those should be read using the file, using Java I/O file or something else, using that API instead, because they're like different concepts. One is literally a file in the file system. The other one is, hey, a resource that resides someplace. It happens to reside in the jar. Yep, good questions, all important stuff. Great question. Yeah, so just in case anybody didn't hear it. So the question was, hey, for a text file, is there a format that needs to conform to? The answer is no. The requirements that I have, well, really the only requirement that I have on the text file is that well, it needs to be text, or at least it needs to be readable enough so that the grader, so the human, the grader can determine that yes, when I add a new appointment to the file, the new appointment is actually added to the file. So don't write it out as a bunch of bytes. Don't encode it. Or don't digitally, or don't encrypt your file or anything like that. Please, it's got to be plain old text and something that the grader can, very easily see evidence that the right data was included there. Any other questions about Project 2 or Project 1? Check the chat. Sweet. Project 1 is due on Wednesday. Let's see here. Oh yeah, maybe I can do that during. Okay, so extra incentive. Oh, and by the way, projects, all assignments, and even POAs are due at 6 p.m. It was funny. I was thinking about it, and I'm like, why do people think stuff to do at midnight? Well, first of all, that's the default time in Canvas, so probably other professors are just like, yeah, have it due there. And yeah, hey, I suppose it was all online. It doesn't matter what time it's due, but it's probably also like a legacy of the fact that, well, two things. I have it due at 6 o'clock because I want you to be in class and not working on your homework, and so then it's due before class. And also probably like is, I don't know, legacy of just like me and my old school. It's like you submit your assignments during class, at the beginning of class or something. So that's why it's there. But yeah, but Project 1 is due on Wednesday, and if you can get submitted before class, while you're all pair programming, what I'll do is I'll run it through the grading script and give anybody a heads up. It's like, oh yeah, by the way, there's like you're parsing the command line wrong, everything's failing, and so I'll try to give you some early feedback on that. Otherwise, I'll ask the graders to grade it over the weekend. Cool. Anything else on your mind before we dive into refactoring? That's good. Okay, so we've talked about a number of concepts in contemporary software development here, and sort of how code is written today. And this is some content that I injected into the class, I don't know, a year and a half ago, maybe 2 years ago now, that I think really helps us do some more advanced things with coding. So, looking back on my time as a student, one of the things that I realized is like, wow, so much of my code was my own. I was the only person that contributed to it. I had to write, some code for, an assignment, or maybe I had a class where I was building something up, over an entire term. But they had a very short lifespan, and I never went back to it. Right? It's not like you're gonna go look at your, code from like sophomore year or something, and then, take another look at it. But then when I got to the real world and I started doing this professionally, I realized like all the code that I write is somebody else. All the code that I deal with is like somebody else's code that was written a long time ago. And I realized the importance of having code that is readable, is consumable by somebody else, even that person is like you in the future. And people talk about legacy code. They're like, oh, it's bad, it's old. It's like, well, I kind of look at things differently now, where it's like legacy code is useful. Right? You look at code that was written before because someone else still cares about it. Someone else is taking advantage of what it does for them. And so then, I've changed my tune. I realized like, well, yeah, maybe it's legacy. Well, first of all, two things. First of all, yeah, legacy code is good because it means it's useful. And also, well, all code is, as soon as you commit it, it's legacy code, right? Someone, has, someone else is going to look at it. Someone else has to work with it. So anyway, when you have the code that people like, people want more of it. They want more features. They want to work better. They, it lives on because it's useful and because it's desirable. And however, code that might seem fit to purpose today might be more difficult to work with in the future because you learn more things. Because as you go in there and add it and have it do more things. It's easy for it to lose clarity or to realize that, oh, well, maybe the approach that we had before to expressing ideas, which is what you do in code, right? And expressing ideas, expressing functionality in code may no longer work. So anyway, um, as code, as more people contribute to the code, and as time goes by, code smells can appear. And so these are aspects of the code that just don't seem right. So things that, again, maybe aren't fit to purpose, but maybe never were fit to purpose. Like names that don't make any sense, or just the layout of how methods are defined and how they interact with each other. Sort of doesn't make any sense. And so then either doesn't make any sense or are really awkward. And so the goal of refactoring is to take code that might be functional today, or maybe isn't functional today, and put it into a form where it's easier to work with. So what we're going to do tonight is we're going to explore code refactoring through an exercise that we're going to take some code, which is smelly, and then we're going to work in small groups to figure out, well, how it smells and what we can do to fix those smells. And then we will refactor it to see what kind of tools IntelliJ gives us, and also we'll write some automated tests to make sure that as we change our code, we haven't broken things, that we haven't inadvertently introduced different behaviors. So that's what we're doing tonight. So as a whole class, we're going to work on this thing called the Gilded Rose Kata. When I was putting together the refactoring lecture, I realized how difficult it is to express refactoring sort of in a static context, in slides, or even a pre-recorded pre-recorded screencast or things like that. It was really difficult. So I wanted to augment the lecture, which sort of goes through the phone book, if you will, various code smells and how to refactor around it, with this exercise where we actually get to see some code, where we get to improve it here all together in real time. And there's a code kata called the Gilded Rose, which was developed and sort of made famous by a thought leader named Emily Bache, who is great. We'll watch a little video by her. Her content's really great. I'm a big fan. And what this kata does is it basically gives you what feels like a really real world problem, which is you basically have a bunch of icky, half working, hard to understand code that's dumped in your lap, and you got to do something with it. And that's what we're all going to experience tonight. So we're going to explore the kata a little bit, sort of learn about the problem domain. We'll watch an introductory video. And then what we're going to do is explore a little bit of the scenarios that might form some unit tests that we need to write. So there aren't really meaningful unit tests for this code. And a very common approach is to write tests for the code to basically capture the current behavior before you start refactoring the code in ways that might change the behavior, which you don't want to do when you refactor. The whole idea of refactoring is that you retain the behavior, the functionality of the code today, but you then change the code to make it easier to read, easier to work with. And so then we're going to work. Are we okay? You good? Okay. We're going to first write some unit tests and make sure that as we then modify the code, that we don't break anything. So let's see here. And then we're going to, so we're going to talk a little bit about unit tests. We're going to write a couple unit tests. Then we're going to work in groups to look at the code base to identify some smelly code. And then we'll use a little cheat sheet that Josh Kaviersky has, Karaveski has to sort of say, oh yeah, if you see this smell, use this refactoring. Also the slides have that stuff. To then brainstorm some stuff there. We'll work in small groups for that. And then we'll spend some time modifying the code, making sure that everything still works. And then, yeah, so that'll take up most of class tonight, and then we'll talk about Project 3 at the very end. That's what we'll do. But first, let's watch the video that introduces the kata. And oh, I gotta share the screen in the right way. Yeah, let's share the screen the right way. Stop share. Reshare the screen again. Not too much for video sharing. full screen this. Don't want to try YouTube TV. Okay. Yeah, we'll watch this for 5 minutes. If anybody cannot hear it on the Zoom, please chat and let me know.
By my estimation, thousands of developers have tried the Gilded Rose refactoring kata. It's by far the most popular exercise on my GitHub pages, with over 4,000 forks. And I've got loads of translations in my repo, over 50 programming languages, most of which were contributed by other people. It's also included in the Arctic Code Vault, so it will be preserved for future generations of programmers to puzzle over why such a bad piece of code ever made it in there. Because fundamentally that's what this is, it's bad code. So why has such a strange little piece of code got so much attention? Hi, I'm Emily Bache, software developer and creator of Saman Coaching. In my channel, you can find content for technical coaches and lead developers. If you like what you see, please hit subscribe and like. This is the scenario. You have just been hired by the Gilded Rose establishment, which is a small inn with a prime location, and the previous developer, Leroy, has just moved on to new adventures.
Goodbye.
The goods sold in the inn are somewhat unusual, and the business rules governing their value are a little confusing. Your job is to develop the system further to support a new kind of product, conjured items. It's all a bit magical and fantastic, and it takes a lot of inspiration from the World of Warcraft, which I've never played, but I'm told all the characters come from that game. You don't actually need to know any of that to do the exercise. Basically, it's an information system with Byzantine business rules and a half-complete spec. Exactly what you're probably used to. So the code is not all that long, but just check out that indentation. We have a serious bumpy road going down there. The logic is, to say the least, tangled. And at first glance, it looks pretty difficult to change anything without breaking the code. Many developers have that experience daily with their production code. But the thing with this exercise is it's not real. So you can try stuff out and discover what works and what doesn't work in an arena where it doesn't matter if it all goes horribly wrong. Once you get the hang of a few refactoring techniques, you can actually clean up the code pretty quickly. So you go from, oh, this code is terrible, I can't change anything, to, no problem, I can fix this. Quite a short amount of time from one to the other, and that's why it's so fun. I didn't invent this exercise. It was originally presented by Terry Hughes in 2011 as a challenge to his colleagues. And I heard about it when Bobby Johnson wrote a blog post and put the starting code up on GitHub. I was intrigued. The code looked bad, and I like a challenge. The thing is, the original code was in C#, which at the time wasn't a language I'd done much work in. So I wanted to do it in Java or Python, my preferred languages at the time. And I didn't find it all that difficult to translate most of it. But the starting point was a little awkward to get a unit and test in place for, so I modified it a bit. And I think I simplified it and made it a bit easier to get going with the refactoring. As you know, I'm a big fan of approval testing, so I also took the time to add a suite of tests in my preferred approval testing tool, Text Test. And when I played with the exercise a bit myself, I thought it might be good to use this in a coding dojo, and I was doing one at the time, so I thought, well, okay, I need to set this up in CyberDojo, which is the tool we were using. It's still up and very useful. You should check it out. John Jaggett invented it. There's a link in the show notes. Anyway, to get it set up in there, I needed it to have a unit test and not text test. So I created just this single failing unit test and added it to the starting position. Having that test there, failing, it's like an open invitation to any slightly OCD programming nerd to come in, oh, I've got to fix that. And then you get drawn in. And I think that's part of the reason for the popularity of it. I really recommend having a go at this exercise. You can pick pretty much any programming language that you like, even UML or XSLT. Yeah, really. It turns out you can write really bad procedural style code in any programming language. And I'm constantly surprised by the pull requests that I get with translations. In fact, I'd like to take this opportunity to thank all of the contributors. So many fun and interesting programming languages. And if your favorite is not in there already, you could fix that. Send me a pull request. Before you do any refactoring, make sure you have some good tests. Either begin with the failing unit test that draws you in and write your own suite of unit tests, or you could try and work out how to use the approval tests that are there with text test. Then you can open the code in your best refactoring IDE, get stuck in. Happy coding!
Okay. So that's what we're looking to do. We're going to look at some ugly code, we're going to write some unit tests for it, and we're going to try and make it prettier or at least easier to work with. So we'll go back to sharing the regular way. So bandwidth. Okay. So let's take a look at the requirements. So I added a directory to the katas directory. So it's the same katas directory that you are all using. So if you want to follow along, you can just pull the latest changes into your checkout of it and follow along there. But it's not necessary tonight. Okay. So here is the specification. So like I said, there's a small in that sells items. And one of the things that we model in this is that every item has a quality and has a sell-by date. And the quality changes depending on how far away from the sell-by date we are. And so then in this model, or at least the model that was developed by the original writer of the code, Leroy, is the following. So every item in the Gilded Rose establishment has a sell-in value, which is the number of days in which you have to sell it. And then it also has a number which denotes the quality of the item. And at the end of every day, the system updates both the sell-in and which decreases every day, and then the quality, which usually decreases, but not for everything, and not under all conditions. Okay, and so let's see, what some of those exceptions are to the rule. So for most items, once the sell date has passed, the quality degrades twice as fast. So it's like, milk that expired or something like that. Now you can't have the quality ever be negative, so it goes to 0. There are some items, though, like aged brie, where the quality increases as it gets older, right? As you get closer and closer to that sell date, it's all of a sudden higher quality brie. You start out and the quality of an item is never more than 50, so it's got an upper bound. And then there's this, like this legendary item called sulfurous, which never has to be sold, so it never has a sell date, and the quality never decreases, so it retains its quality forever. And then also at the Gilded Rose, you can buy backstage passes, which have quality that increases as it gets to its sell-in date, or sell-by date. And so then, if there are 10 days or less until the sell-by date, then the quality increases by 2. And when you get 5 days before the concert or wherever the backstage pass gets you into, then it increases by 3. But like once the concert is passed, well, then it has no value, not even as memento, and so then the quality drops to 0. And there's a couple other things more. And then also there's this new thing called conjured items, and this is something that Leroy didn't implement. This is like the next thing that we have to implement. And here, the thing about conjured items is that they degrade in quality twice as fast as normal items. So instead of going down by 1 every day, they go down by 2. So a couple other rules, a couple other constraints. There is a method called update quality. As a matter of fact, we can go and look at that now in the, sorry, this is not the right repository. Close that out. Gilded Rose has an update quality method. This is the method. We'll take a look at that. So this thing, we can update. We can make any changes we want to that. So this code is good. However, we can't change the item class or the items property of Gilded Rose. So these things are static because there's a goblin that'll come and get us. Whatever it is, just constraint they put on for the sake of the activity. And so then again, you can change most of the code. You can change the update quality method, but items need to stay the same. Okay, great. We can make things static, but we can't change them otherwise. And then, oh, by the way, an item can never have its quality increase above 50, but sulfurous can go up to it starts at 80 and never alters. So if we just take a step back, basically what we've got is a specification with lots of little minor, what seem like crazy details, but I'm sure they matter to somebody, right? That we need to implement, and a bunch of like she says, Byzantine business logic, and then a request for something new to be added. Before I move on and start looking at the code, those are people sort of get what we're doing here, though, right? We've got some crazy business logic to implement. Anything in particular you want to dive into on this? Yeah.
As a business analyst, rules 1 and 3 seem to be there's
Oh yeah.
For H3, if it's past the sum date, does it increase by double? Or that would be that would be a question I would bring back to
Good point.
the customer, because that one seems unclear.
I like that.
Yeah.
And more so because there's already an implementation of it. We need to understand what the code does now because there's probably someone relying on that, right? And so that's a really good unit test to write. Say, okay, great, how's it working right now? Make sure that we can we capture that. And sorry, did you have something too? Yes. Yeah. When there are 10 days or less left, and then Oh yeah. Well, actually, age breed increases. I guess it increases by 1, but then backstage. I know, right? Yeah, it's all this kind of crazy stuff. Yep. Nice. Anyway, okay, so that's kind of those are the requirements of what we're doing here. Okay. Now, originally when I started doing this, I had everybody break up into groups and brainstorm given one then for these, but it took a lot of time, and because things were so complex, it really wasn't. It was rehashing it every time we did it wasn't very effective. So I thought instead what we'd do to familiarize ourselves with the code, we'd implement some unit tests for this code based on this business logic, just to make sure that we understand what we're doing, and also then to build up. Honestly, I think of the unit test as kind of like this protection that we have from introducing bugs, because what it'll do is it'll give us feedback if we break anything. So, I guess one more thing before we dive into that, though. In the video, she mentioned that there were these test fixtures, and she used this text test thing. I'm not familiar with that tool, but I think what it basically allows you to do is say, oh yeah, when you run a main method, here is the output that I expect, and it'll compare the two. It's okay, well, that seems neat. So what I did was, and so then, actually, where is it? Oh yeah, it's this, it's this test text fixture. Text test fixture main method, which prints out a bunch of stuff. So I'll make it a little bit bigger so we can see it. It goes through and it creates a bunch of items. And the items range from a +5 dexterity vest to sulfurous to some backstage passes. And it invokes this item constructor, and the constructor takes 3 parameters. The first one is the name of the item, and then the second is the sell-in, and the third is the quality. Item is this class that we can't change. And, and it also creates a new conjured item here and says, oh, yeah, it doesn't work correctly. And then what it does from these items, and there are whatever, like 10 of them, it creates a, excuse me, a new Gilded Rose object with those items. And then, and then it will, because it's a command line program, it takes the number of days then to age these items by. And then it goes through and it prints out, hey, what day we're in, and then it prints out the name, sell-in, and quality for each one of the lines. And it calls update quality from Gilded Rose. And update quality is the thing that actually goes and updates all of the quality and the sell date for everything. And this is the ugly code. Now, we're not going to look at the ugly code quite yet. We're going to be doing that after we write some unit tests. But as you can see, it's ugly because there's lots of indenting. There's lots of references to fields, items, I's all over the place. It's like kind of hard to figure out what all of this stuff is. It's pretty long. And so then, okay, this is what then we need to clean up so we can then implement the new kind of the new kind of item, this conjured moniker. So when we run this code, we'll just run the main method here. We see it outputs that there are 2 days, day 0, and I shall make this a little bit bigger. This is the output that we expect for day 0 and for day 1. The details aren't so important right now. But I think the thing that is important is that we have, what's provided in the kata, is the output for 30 days. And so that's all here in this file. So this is basically the code that we want to keep working. This says, hey, listen, for all those 10 items, go run 30 days of simulation of updated quality. And we want to make sure that this keeps working as we refactor our code. And the way we'll do that is with this integration tests that basically goes through and calls the main method. This is using invoke main, just like your integration test for your code is. And it runs over with 30 days. Make sure nothing is written to standard error, and that instead the contents basically we go line by line and make sure that the output of what was written to standard output matches the contents of that 30 days of standard output txt. This will be another check that as we change the code, nothing breaks. So as things should stand, if we run this, everything should pass. Oops, what didn't it like? Oh, I need to run it clean, sorry. Let's do it clean. This is something common that you see in IntelliJ, like if you get this, JUnit Jupyter failed to discover tests, I think what almost always fixes it is doing a maven clean on the command line and then running it again from IntelliJ to see if that actually works. Yep. Okay, so good. This passes right now. And we'll come back to this test and the other unit tests that we write after we make every refactor. Okay. So now, let's go through and write some unit tests for for that item class. So let's see here. I think this is sorry, what are my tests? Tests. Oh, yeah, Gilded Rose test. Oh yeah, this is the this is the test that comes out of the box. And remember, how she said it's broken. So here's what happens. So we create a new item called foo that has a sell-in of 0 and a quality of 0. And guess what? It's a unit test. It's like totally bogus. And so we call update quality, and it says, great, the name of the first item should be fix me. Well, that's not happening, right? And it's not. It says, oh yeah, it should be foo, but was fix me. Okay, so let's make this one pass. As a matter of fact, we'll make this one pass, and then we will, let's, instead of using like the old school JUnit assert equals, that's nice, we'll just use assert that from handpress, because that suits. That's what I like to use. And we'll assert that app.items.name equal to foo. And we'll run this again. A little bigger, sorry. Nice. And then I see an opportunity to do a little bit of refactoring here. And so then we'll take, because I see that foo, that string foo duplicated, so we'll say refactor, and we'll say extract variable, and we'll replace all occurrences of it, and we'll call it item name. There we go. And now when we run it, it's a little bit nicer. Okay, sweet. Okay, so so this is kind of a silly unit test. It doesn't really, the name, the item's name never changes. So I think this is very useful. We'll leave it there, just for grins. Let's look at another one that's more interesting. So we're going to start out with a Gilded Rose that contains an item with a selling of 10 and a quality of 10. And when we call update quality, we should expect that the item will then have afterwards a selling of 9 and a quality of 19. So let's see if I can get that right. Actually, let's see here. I want to keep that on the screen because I'm not going to remember all this stuff. Can I do this side by side? Yeah, I think I'll be able to do that. Okay, so we're just going to create a new test here. And that doesn't help. We're going to call it, I don't know, normal item. Let's see, quality of normal item. Quality of normal item decreases by 1. Oh, wow. How did it know that? This is beautiful. Okay, so I just want to make sure that the AI got it right. Goes from 10 to 20, selling of 10, quality of 20. We'll create a new Gilded Rose, we'll update the quality, and I don't want to use assert equals, I want to use assert that. How do I? Yeah, okay. It'll learn. Assert that. Oops. Apps.item0 quality equal to 19. Yeah, quality, and if the sell-in is 9. Sell-in is 9. Okay, let's run this one and see how it does. Nice. Okay. So that one passed. Good, good, good. So what we're doing here is we're writing unit tests to, this is not refactor unit tests, right? Because the code is already written. This is, again, having that protective bubble around our code. This is having unit tests that validate the existing code. This is actually a very common technique when dealing with existing code, dealing with legacy code, is that you write tests to explore how the problem works. Like you were saying, it's like, oh yeah, when you have this particular condition, how does it work? So we're going to do this for a little bit, and then we'll break out and start, have you all look at the code. But I just want to add a couple more here. Let's see here. The second one is, this is aged brie. Quality goes up. Okay, quality of aged brie increases by 1. Wow, it gets it pretty right. Although I don't want to use that. I want to have selling of 2 and a quality of 50, and then let's see here. And then we have the sell-in goes down to 1, and this goes up to 51. It might have been right before. Sorry. Sorry, what? Oh, you're right. Thank you. Yeah, I don't know where it came with 50 then. Yeah, I know you. How did it know that though? It's in a Google Doc. Yeah, I don't know. It freaks me out. And then we'll run this one to make sure that that is true also. Nice. You know what? I kind of want to do a little bit of refactoring here because we have a lot of boilerplate code. So, okay, no, I kind of want to refactor here. Let's commit first. So start adding unit tests for the Gilded Rose. So I'm going to make this big because I'm going to refactor. So as I'm writing these tests, I'm seeing a lot of duplicate code, right? And we're basically have like the same pattern over and over again. So I think here's what I want to do. I want to try to eliminate some of this duplicate code. So I'll do the following. I think I want a method where I pass in the item and then I have it return item 0 so I can assert the quality of it, or I can assert, the cell and the quality of it. So let's see here. What am I going to do? I want to introduce a variable here. And we're going to talk a little bit more about all this stuff in just a bit, but I want to show you some things first, and then we'll get back to the details in a moment. I want to extract a variable, and I'm going to call that, I'm going to call it item. Oops, I want both instances. I want to call it item, and then I want to take this item up here, and I'm going to put that into a variable also. I'm going to say extract variable. I'm going to call it item. I'm going to call it original item. And then basically, then I'm going to take all of this code right here, and I'm going to put it into a method. I'm going to introduce a method with all of that. And it's going to take in the original item. It's going to create the Gilded Rose, it's going to update the quality, and then it's going to return item 0. And so I'm going to call it, and I'm going to call it get item. I'm going to say update quality of the original item there. Nice. And then, let's see here, what is it saying here? It's saying local variable item is redundant. I can inline it. I'm going to do that. And I'm going to do the same thing with this up here. I'm going to use that same refactoring. I'm going to say inline variable. Nice. So now I've got, oh, it looks like I need to reformat some things. I don't know why those are indented like that. The indentation's all weird here. I'll fix the indentation later. So, okay, now my test is a little bit cleaner now. I only have 3 lines instead of 5 or 6. And I'm gonna run this test again just to make sure that it still works. Nice. Cool. And now I'm going to change this one down here to basically do the same thing. So now I'm going to say item equals update quality of this new item here. Happy with that. And now I don't need any of this anymore. I'm going to replace both of these with just item. Nice. And I'm going to run that too. Okay, I'm just going to run all the tests just to make sure that everybody still works. Yep, everything still passes. Sweet. And I want to clean up the code. I don't know what the menu is, but I know the keyboard shortcut is. It's Alt-Command-L for reformat the code. Oh, everything looks much nicer to me. I like 2-space indents. Great. Okay, so what I just did here is I refactored my unit tests, right? Because I wanted to have just a more compact method for more compact code for doing all these, because we're going to do a lot of wash, rinse, repeat. So you can still refactor your tests, just like in refactor. It's just that you don't have a red test that goes to green. You want to start with a green test. Cool. Okay, so let me commit this and push it up. I'll say refactor unit tests to remove duplicate code. Oops, I don't have letter Z there, but too late. Nice. Okay, let's just add another unit test. Oops. Here, let's do this next one, the age brie of 2 to 50. Actually, this one is that it's a maximum. Yes. Okay. So here, avoid maximum quality of aged brie is 50. How does it know that? 250. Oh, look, it even figures it out to use that, and then it goes to 1 and 50. That's really nice. Like AI. I mean, come on, right? Yeah. Although I don't know, how are you finding it? Is it sort of like is it fast for you, or is it like are you able to follow along when the AI writes so much stuff? But yeah, right. Yeah, you gotta figure out when it's like, yeah, doing something wrong. Yep. Nice. Okay then. Cool. Okay, so everybody see what we're doing here. We're going to develop a series of unit tests for this this code that we have, the Gilded Rose, that basically creates an instance of Gilded Rose, updates the quality of its items. Okay. So I don't know. I'll put more of these here while you're doing something else. Okay. So that is those are some unit tests that I'll flesh out so that we've got a nice suite of tests to make sure that we haven't broken anything as we refactor. And now it's time for you all to work together on something. So, you probably noticed here in the update quality method, there is just some ugly, hard to read stuff. We're doing all this comparison to strings. We have like all these hard coded numbers. We're incrementing quality. Sometimes we're decrementing it. Right? I find it's really hard to like reason about and to understand. And to me, that's a sign of some smelly code. So what I'd like to do now is have everybody break up into small groups and then look at this code and use things like the content, what I call out in the code refactoring lecture, and then also this cheat sheet from here. It's really kind of hard to read though. To identify, to identify some smells in code, and then identify, hey, something smelly. And then like say, hey, here's a line of code, or like here's where in the Gilded Rose class you smell it, and then some ideas of how we could refactor it, how we could make it less smelly, how we can make it easier to work with. So I hope everybody had a chance to read over the code refactoring lecture, or at least has a little idea of what we want to work with. Sorry, does everybody have access to the document I posted about it in Slack? Or is there anybody else that doesn't have it? Anybody remote who doesn't have it? Yeah, and I'll post the link on Zoom too. Thanks. Okay. Let's see here. How many of you in class are also on the Zoom? 1, 2. Okay, so I'll make one. I'll just have one breakout room for Zoom then. And then here in the class, let's have 2 groups working on this. So like a group of. Are you heading out? Okay. Have like maybe 2 groups of people working together. And again, brainstorm. Look at the code, identify some code smells, and say how you take care of it. Let's do that for like, I don't know, 10 or so minutes. Okay, so that was some ugly code, wasn't it? Yeah, I heard a lot of good chatter here, and I was looking over all these all these things. These are really good ideas, and it looks like, yeah, you identified a lot of things. It'll be really great. So how about we take a 10-minute break, start cleanse our palettes, and then we'll come back. We will learn about IntelliJ's tools for refactoring, and yeah, implement some of these. See if we can make this code a little better. Yeah. See you in 10. Okay, back from the break, and there was a question that came in, I guess, a little while ago, maybe right before a break. For project 2, should we write unit test within text dumper test, and text parser test and integration test will be same like project 1 test? Yes, in general, yeah. The unit tests for text dumper and text parser are there to basically show you that you can write unit tests for code that does I/O type things. And there's some subtleties there in terms of how it's testing, because it's using things like like the text dumper test. Use it. Maybe I should just show you. Open up the repository again. So looking at the text dumper test. The text dumper takes a writer of any sort. And so here in the test, I pass in a string writer, which provides the writer interface over a string in memory. And so what you can do is I create a new appointment book, and I create a text dumper that will dump to this string writer in memory. I will dump the book to the text dumper, and then what I can do is I can get the string of text that was written to that string writer and assert that, yep, the owner name is contained in that string. This allows you to write a unit test. Notice there's no file involved here. No file is written. Instead, what you're doing is you're writing to a buffer in memory. But because the text dumper programs to the interface, because all it takes is a writer object, it doesn't care where the destination is. It doesn't care whether there's a file. It could be like a socket that writes off someplace. And this is not only an important design principle, this will help in Project 4 when what you're writing to is not a file on disk, but what you're writing to is the response of a REST API call. Kind of skipping ahead, but that's why, that's like out of the box, I have the text dumper using a writer for a generic writer and not a specific file writer or to a file. And so I encourage you to retain that pattern in your code, so you have to go back and change it later. So then what I suggest you do is you start taking these tests and then augmenting them with more and more test cases. Oh, and then the other one right here, this is also kind of a favorite of mine. Like whenever I have like a writer and a parser, I create some test data, I create some test appointment book, and make sure that that you can write to a file and then also read it back, and that you have exactly the same stuff that you wrote. This also demonstrates the @tempter annotation in JUnit, which will basically provide the method, inject the method with a temporary directory. That's great. And then text parser test, since we're talking about it, this is where we get the tests. We get these text files as resources loaded here from the test resources directory. So here's like valid appointment book.txt. So out of the box, this is a valid appointment book, because the only thing in the appointment book text file is the name of the appointment book. But then the parser test will use the resources API to load that text file as a resource. It'll then create a text parser, which takes a reader, in this case an input stream reader that's created around that resource that was written. It will parse it, and then you assert that the appointment book that's returned by the parser has an owner name of test appointment book. So here you could augment this one to add as you have support for the description of the appointment, and then the appointment begin time and end time. You can add more capabilities to these unit tests. Good question. I hope I answered it. Okay. Okay, back to our refactoring kata. So let's see here. Before the break, oh, maybe there's a follow-up question. Excellent, thank you. Before the break, you all worked in small groups to brainstorm some smells, to pick out some smells in that code. Meanwhile, I started implementing the test cases that were there, and then like towards the end, I was just basically having Copilot, dream up things until the stuff it dreamed up was just like kind of dumb and redundant and stuff. So what I've got here, if I go and I run all of these tests, well, I can see it down below here. I've got, I don't know, a dozen or so tests that, 17 tests that all pass right now, which is good. So actually, I was kind of curious about the code coverage that I got. So I'm going to run maven clean. I'm going to run maven w -p greater clean verify to see what kind of code coverage I have, to see if there's any code that isn't covered by my unit tests. It'd be interesting if I'd done this at the beginning to see if there's anything that's it's not. Oh, let me do the integration test. Let's see here. What did it say? Oh, I guess I don't get a code coverage report. Instead, I will open up the Coco report. Oh, I've got 100% code coverage. That's good to know. Now, this doesn't necessarily mean I've exercised every test case, but it means I've exercised every line of code. It tells me something, right? So I guess like, okay, I feel good enough to move on. Yeah, right. Yeah, so given all the branches, okay, that's kind of nice. Although now I'm kind of curious about what it was before. But anyway, sweet. So then, let's talk about some of the smells that you saw. So we got like a long method, because definitely, yep, a long method's a lot of lines of code. We're taking quality of the name to string rather than some other general property. Okay, yeah, subclasses. Yeah, so I think, yeah, that was good to pick up on the fact that, sorry, let's go find Gilded Rose here, upper quality, oops, nope, upper quality. Yeah, that what we're seeing here is lots of like duplicate strings, and I saw that, and like here's backstage pass again. Yeah, oh yeah, because we use some int number values. Yep, lots of constants. Same thing with hard code. Yep, hard code numbers. There's complexity. So many good ideas here. Excellent. Okay. Sweet. Okay, so we got lots of good ideas for how we can improve it. We'll take a look at these in detail in a little bit. But first, I want to talk about IntelliJ's tools for refactoring. So you've seen me use these a couple of times, but I just want to take a moment to walk you through some of the ones here. I've got a couple of links off in the documentation, this is something. So code refactoring again, is meant to not change the behavior of the code, not change the functionality, but just to change the form, the factor. That's why it's called refactoring. So usually it's changing the names of things to make it more clear, or moving the code around in such a way, breaking up big code into little code, removing duplicate code, things like that. So IntelliJ, like any good tool, makes these things easy. And actually, it's really nice because having a tool do your refactoring for you, at least the mechanics of the refactoring, is much safer than trying to do it yourself. I remember trying to refactor things back when I was using Emacs like a million years ago, and it was really easy to like miss a place. And you rename a method and it's called 7 times and you only get 6 of them, and then things don't compile. Right? It was much slower. Same thing with like extracting the code. I think you saw how easy it was to just like create a new method, didn't have to worry about cut and paste errors, things like that. So I just have a screenshot here of the of the refactor menu, and the description over here on the right of all the kind of stuff that you can do. So I think we might have seen rename, maybe not tonight, but I'm sure we'll use it again. And we saw extract variable. So I was like, hey, here is an expression. I'm going to put that into a variable that I can use multiple places. You can also extract, you can also take an expression or a value, put it into a field, put it into a method parameter. And you can also do more object-oriented type things about moving methods around. Now, maybe we'll see that a little bit later tonight, or maybe we won't. I don't know if we'll if we'll end up using those kinds of things. But when you end up with multiple classes and stuff, when you want to say, oh look, I've got duplicate code in two classes that maybe share a common superclass, you won't be able to move the methods up and down the class hierarchy, usually up the class hierarchy. Inline is also something that I use when, hey, you've got a variable that maybe isn't terribly interesting. Maybe it's only used once, so maybe you want to take the value of that variable and use that instead of the reference to the variable. That's what's called inlining. And then again, yeah, pulling members of classes up and down the class hierarchy so that they can be used to serve. You can move a method up in the class hierarchy so it can be called by more subclasses. So we'll be seeing some of these tonight in our refactoring. Okay, let's dive into it. Where do you want to start? So, guide me here. So, what are some of the things that that you want to start refactoring? Oh, yeah, the condition. Okay, good. Okay, what's the first conditional that you'd want to change? Well, it's highlighted in yellow. Let's see what IntelliJ says. For loop can be replaced with enhanced for. So enhanced for is a different language syntax. So I'm going to Alt Enter here and say replace with enhanced. Oh, it even gives me a little preview. Yeah, it's kind of like a for each. Let's just give it a try. See what it looks like. Yeah, okay. Oh, that's nice. It also got rid of that whole item sub I thing, which is cool. Okay, that looks a little bit more readable. I'm going to run my test again and see if it still works. I'm going to run my test again and see if it's still whatever. I will. Let's do it from here. Say run again here. Oh, good. They also pass. I'll also run my integration test to see if it still passes. I found the integration test is way more sensitive. Oops, it didn't like it again because of, oh yeah. Oops. Let's try this again. Okay, well that passed. So yeah, do we like this refactoring? Yeah, question. There's something about the integration tests. That sometimes after you run a maybe clean verify and you do the Jacoco code coverage, all that kind of stuff, it messes up IntelliJ. I don't know what the problem is exactly. It's probably because IntelliJ doesn't exactly know the integration tests are tests. I don't know. But yeah, but when you see that, could not find Jupyter Engine or wherever that was. Yeah, and yet after you do a clean, it's fine. So I think IntelliJ gets confused. So yeah, it's easy to clean up. But yeah. Okay, well, let's check this in. Let's see here. Oh, and as I'm refactoring, I want to go in sort of baby steps. So it's like, hey, I've done this. Look, a lot of code has changed. I'm going to check it in so that we can, verify that we have a known good state as we consider more refactorings. So let's see here. Use an enhanced for loop when iterating over items. Okay. Oh, what's next? Oh, okay. So have a maximum. Yeah, it's constant here. I like that. Yeah, it does appear a few times. Yeah. Okay. Yeah. Okay. And so yeah, good. I like that. So I can use refactor, and I can say extract constant, and then it's maximum quality. What do you want to call it? Maximum quality. Great. Right, and that puts a constant up here. It's right. It does all the right thing. And did it replace it in all the places? Oh, it didn't. Well, that's a bummer. Okay. Maximum quality. Maximum quality. Maximum quality. There's 50. Nope, 50 is only one place. That's good. Okay, we'll run the tests again. We'll run all the tests. That one should be pretty easy, right? Yeah. Use put maximum quality. Constant. Yeah, it's one of those. Is it a magic number? Maybe it's kind of a magic number. But anyway, yeah, I think having, because right, I mean, this makes it like way easier to read. You know what that 50 represents, right? And that's why you do this. Again, to the computer, to the JVM, to the compiler, it's exactly the same value. You're making the code easier to read, easier to work with, so we can change it later. Now, speaking of constants, what do you think about like all these like names of things? Want to extract some constants for them also? Yeah? Yeah. Let's do that. And let's see here. Refactor, extract constant, HBree. And then let's do the same thing for this. Refactor, extract constant. I can need all of that. Yeah, I'll just say backstage passes. I'm sure that's some really hilarious reference for somebody. And I looked it up one time. Yeah, okay. Constant. I start using shortcut. Shortcuts now. So Purus. Oh, it didn't find the other. It's interesting. Yeah. Huh, I didn't. So usually it's smart enough to know that to go and look for other places. Wow, that's really interesting. Maybe. Yeah, maybe. See, did I get them all? Yeah, it kind of looks that way. Run again. Oops. Do that again. Cool. Okay, so then we will extract more constants. And okay, things are getting a little easier to read now. Wow. Okay, so what's next? This method is so unwieldy. Here's this yellow right here where it deletes something from itself, so replace that with 0. Thanks, IntelliJ. Okay, well, where do we take it from here? Mhm. Oh, okay, so basically, yeah, have this just be minus minus and this be plus plus. That sounds good. Okay. Yeah, I'm going to do like a text search and replace here. So I'm going to say edit. Oh geez, I don't know where replace is here. It's Command R. So I'm going to replace this one. And, oh yeah, there's 4 times. with, oops, with, let's see here, quality plus plus. Replace all. This, and then replace this with item quality minus minus, and then cell in, yeah, -1. All right. Yeah, no, that makes it a little easier. Cool. Okay, let's run test again to make sure it's okay. Okay, I do want to run the test fixture. Nice. Okay. Yeah. Okay. This is way easier to read now. Hmm. Yep. Oh, like where? Yeah. Mm-hmm. Yeah, right here. Yeah. Okay. What is? Yeah. But we do increment quality right here. So right, yeah. This is where it's subtle, right? Yeah. You gotta be, you gotta be careful of that. Yep. Interesting. Okay. Uh, line 47, 2. Yeah. Oh, I see. Yeah. Okay. Oh, like all these right here, because these are end up being all ands. Oh, nice. Okay, there you go. I like that. Yeah. If it's, oh, yeah, that's a lot there. Okay, let's see if we can do that. So 40. Sorry, you say 40. It's like all this right here. And then, yeah, but there's all those ifs, else's in there. So, let's just give it a try. And we've got tests. So let's see here. I don't have any local changes. So yeah, let's just say this and that and that and that. And then, yeah, but now this else gets a little wonky. Okay, that's cool though, right? We can just, look, you can just undo it like that. Yeah. Uh, hmm. Let's go back. Is there anything in cool documents? That, yep, yeah, okay. Hmm. Yeah. That is super confusing. Right. Yeah. Whew. Right, it is, yeah. Now, you know, one of our suggestions was, hey, let's get some objects in here. Um, I wonder if we've reached a point of diminishing returns with this code where we should start instead introducing objects. I don't know. What do you think? Yeah. I mean, yeah. So let's see here. Of the unique types of the unique kinds of items, like what's the simplest? It's not the default one, but like the one that has a name associated with it, like aged brie. Yeah, I mean, yeah. Actually, well, compared to sulfurous, well, I can't remember. Like, what's the deal with sulfurous again? Oh yeah, yeah, yeah. What's funny? Do you see? Yeah. Do we have any tests for that for legendary items? So I don't think that even what even denotes a legendary item. I know, right? Yeah, the spec, but yeah, like I don't see anything. Let's see here. Is even that? Well, let's look at the. Oh, let's look at the text. I mean, none of these is legendary, is it? Do we even know? Oh, is that what it is? Actually, yeah. Let's go back to the. I don't have it up here anymore. The. Okay, funny. Oh, I guess it never opened up here in the first place. It's probably still in the browser. Um. Oh, okay, yeah, yeah, yeah. So sulfurous never has to be sold. I don't know what that means, or decreases in quality. So let's take a look at the tests for sulfurous. Sulfurous. Quality of sulfurous never changes. Quality of sulfurous never decreases. Okay. So then, yeah, this does seem like the simplest one somehow. So then, let's start by extracting a class for this. Okay. So let's see here. So now let's refactor this. So here's what we're gonna do. Let's create. Yeah. Let's. Okay. Let's have a new subclass, and I'm going to stop. I'm going to. Why is it indenting too much? Anyway, so I'm going to say the following. If item instance of, and we're going to have like this kind of lame way of doing it first, of sulfurous. What else sulfurous? Well, no, it's red because it doesn't exist yet. So I'm going to create the class in the Gilded Rose in the main. We'll come back to you in a moment. It's also complaining that what? Inconvertible types cannot cast a Gilded Rose item to sulfurous. That is true because, let's see here, I don't want to cast. I want to say, oh, I can't. I understand. I can't say that it extends item. It extends item. Oh, what is it like? No zero argument constructor. Okay, so create. Oh yeah, can create a constructor matching super. Okay. Okay, so now we've got a sulfurous one. So if it is sulfurous, then we will say, then we're going to cast it to a sulfurous instance and then item. And then we're going to invoke an update quality. Update quality. Not the Gaelic spelling. On that. And put it on there. And then we're going to return here because the whole idea is that we're basically, I know the word I've heard used to call this is called strangling the code. So basically, we take more and more logic here, which is like awful. We move it into other code, and eventually this all becomes dead code. We can delete it and make sure, right, and then it's never called again. Okay. Well, so now, if we run this code, if we run these tests, I would expect to see the sulfurous related tests fail because, oops, okay. How did that? Oh, yeah, of course, because we didn't we can change these to be sulfurous. This. Nice. No, it still passed. Why did it pass? Oh, because it never changes. Haha. Okay. So that one isn't terribly interesting. Although, okay. But this does actually let us do some other refactoring things here. Because like now, I'm going to assume that all sulfuruses have the same name. I don't really want to pass the name here anymore. So I'm going to do the following. And this would be, I think this would be a nice refactoring. So I basically want to get rid of this parameter here, and then just always have the super, basically always have this name that's spent to the superclass be that constant. And that constant lives right now in the Gilded Rose class. So here's what I'm going to do. I'm going to do this. I'm going to use a refactoring. I'm going to move it. I'm going to say move members. And it says, okay, great. It's going to move this sulfurous field to a different class. I'm going to move it to sulfurous and then refactor it. Proof it goes away there. And now you should see it appear. Yep, there it is there. Now I'm going to say, well, I want the name to always be sulfurous. IntelliJ says, hey, listen, you're not using this parameter anymore, and that's right. So I'm going to safe delete that name. This is another refactoring. I'm going to safe delete this parameter. And now in the tests, it's gone and removed it from the constructor call. Right? This is nice. So I'm getting rid of magic strings. Now I can run things again and see if it still passes. Okay. I realized that I also want to change this guy. So now here, these two become sulfurous. I don't need this anymore. I probably should have done this before, so that refactor would work. Okay, so sulfurous here. And now if I run the integration test again, oh, it failed. Ooh, it failed. And it failed like in the most unpleasant way because it's so hard to tell what the difference is. How did I do this before? Was that? Yeah, I know, right? Because like, oh, what if? Oh, do I have other? Oh, this is for 30 days. Okay, so this is the whole 30 days. How did I do that before? I want those same items, but just for 1 day. So, oh yeah, maybe I can just do it that way. Let's see, yeah, what happens if I just change this to 1? Well, no, that's probably not what I want. How do I want to fix this? I basically want to call, oh, I know what we can do. We can just maybe run it by hand. What is it supposed to, what should I expect? So if I just say the text test fixture and I run this, let's see here. Oops, let me move this out of the way. If I run this, it will just do 2 days. So minus 180. So yeah, it doesn't change over 2 days. Right, so now I'm like, what do I do? Right, it's broken. I don't know. So like, I guess now I need to figure out like where it broke. So you know what? That was a pretty easy set of refactorings. So I think, wow, why did that break? So like, now I'm wondering like at what point did things break? And so I'm like, oh, I know what I'm gonna do. I'm gonna shelve. No, I can't. Should I shelve my changes? I really don't have to go back and refer everything and start over. That might be the right thing to do. So actually, yeah, what I'm going to do is the following. I'm going to, oh, I really wish really wish I knew. I'd like to keep my sulfurous class. Maybe I can revert everything else. So I'm going to revert and roll back all that. And there's nothing wrong with this. This is why we have GitHub, right? Okay. And so then, oops, that still says it changed. Okay, so revert that stuff. And now let's go back to my pictures. Maybe we broke something before, and because I haven't run this one in a while, I should know better. Okay, so that's passing. Okay, so something we did broke it. But that's okay. Let's just go slow on this one then. So then, and let's use this as our guys, our test. So here we had added a check right here. We said if item instance of sulfurous, then oh, I said break and not continue. Oh, that would have done it, I bet. Okay. What? Did I return? Oh, okay, there you go. Nice, because we don't have any unit tests that have multiple items. And so then, okay, yep. Yeah, and then, yeah, continue. So actually, yeah, is it, yeah, if we had, did I say return? That would probably break it straight up. Nice. Wait, really? Oh, because I didn't change this to also use sulfurous. Yep, that broke. Okay, and so now, yeah, our hypothesis is that, yeah, this return is going to be busted, and so, like, let's just have it continue. Okay, good. So that was, here again, isn't it great that we have tests? Because otherwise, hey, I made a simple mistake, and I found it very quickly because I had tests. Right, okay, awesome. And so while we're here, let's also then go in and replace the unit tests here with a sulfurous and sulfurous here, and then sulfurous here, and let's run these tests again. Yes, we'll do that next. Yeah, nice. And then I think there's one more thing that I wanted to change. I wanted to go back to Gilded Rose, and this use of sulfurous I want to replace with, so I want to get rid of this field. And so I'll use sulfurous dot sulfurous here. And then I want to get rid of this, this field, so I'm going to inline it. Because this field is used right here. I'm going to inline, because this is the sulfurous that's on Gilded Rose. I want to replace it with sulfurous dot sulfurous. So I'm going to inline that field, all three usages, and remove the field. So much nicer. Sweet. Okay. Awesome. Okay, and so now I should be able to run all of that and have it pass. Nice. I should be able to then run my test fixture and have it pass. And as a matter of fact, okay, I'm getting nervous. There's one more change I want to make, but I'm going to commit this first because it's all working. So make sure to commit all my changes. And I say introduce a sulfurous class. So I have a nice, good stopping point on my unit test pass, so I'm going to commit this. And then there's something I noticed here in Gilded Rose. You know, the fact that we're still referencing sulfurous here, this should be dead code now, right? So this should never get there. So what I'm going to do here is I'm going to say the following. I'm going to say throw new illegal state exception. This should be dead code. And every place that I see this sulfurous being used, I'm just gonna like throw these exceptions now. Oh, good. It's saying like, why did it light up here? Oh, it's always true. Oh, interesting. Ooh, interesting. Wait, what is this saying? Oh, this is so weird. It's like, right. So, oh, because look, okay, look, because this is only if it's quality. So this is never going to be true anymore. I don't need it anymore. It's going to throw a dead code exception. Oh, it didn't like it. So it clearly, oh, it got here. How did it get there? Oh, if it's not equal to solve for us. Okay, you know what? That's bogus. Okay, so then, okay, so maybe I still do need this logic. You're right. This is not equals. Okay, nah, that's not okay. Never mind. Never mind. Okay. Oh, good point. Okay, so great. This is so yeah. Let's then. So basically, we don't need these checks anymore because, as you point out, that's always going to be true. Okay, so let's then let's. Oh, I know. Let's. Is it always that same is not? Oh, okay then. Great. Let's extract this into a variable. Yeah. And so let's extract this. Let's do a refactor, extract variable, and we'll say, oh, it doesn't like it. We will extract this into a variable, and we will call it all three instances, and we'll call it is not solve for us. Make sure everybody still runs. Great. And now this will always be true. Great. Now I'm going to inline this every place. And now IntelliJ is telling me that this is always true. So now it'll help me remove braces from, no, how come isn't, so then I should just delete this. Why isn't it letting me delete that if statement? I don't want to convert it. No, I thought it would delete it for me. Okay, so let's go through here. And then where's the next type? Here's another one. And here's another one. So again, what we're doing is we're very like methodically going through and cleaning up the code to make it smaller, to make it hopefully simpler. So let's run those tests again. Yay, that still passes. And then let's run all of these tests again. Yay, they still pass. Well, this is cool. So this is what you do when you refactor code. It's like, what I have to admit, the thing about this code is that it's scary, right? I don't know how to work with this code. And we saw it's like really fragile. Like, oh, okay, yeah, I can just do that, right? No, you can't. This is why you need the test to discover the fragility. But by removing code, we're making it simpler. Remove a logic related to sulfurous, sulfurous, to make the code simpler. Nice. Okay, but yes, the next thing we would do is we would like do something for aged brie, and I think we'd have the same thing where we would have, yeah, we just implement the the logic there. But unfortunately, we don't have time for that tonight. Maybe I'll do a bonus cast this weekend or something like that if you really want to see it, or anyone wants to try on their own, feel free to do so. But yeah, and so that's what we'd do. We would say, okay, let's take aged brie next. Yeah, that's probably it. And then we would do that same thing. We would try to either, I'd probably start just implementing it from scratch, an update quality method there. And then relying on my unit tests to tell me that I've implemented it correctly. and then delete the code related to HBRE, and again, simplify this method until ultimately we've moved all the logic into various classes. Cool. Okay. So anyway, those are the kinds of things I wanted to show you tonight about refactoring. I still have to talk about Project 3, but any thoughts about refactoring? Is this something you'd seen before in your classes? Have they talked about, how to modify code, how to evolve code using these kinds of techniques? No, not so much. Maybe sort of intuitive. Okay, cool. Well, good. Hope it's something new. These are the kinds of things that you'll have the opportunity to apply in your later projects, right? As you start getting into your project 2, you might find opportunities to refactor things in your main method, especially, right? That's the code that's going to change more and more as more as more options are added. And actually, in Project 3, you'll see that there's some things about the format of the command line that will change, that will cause you to modify the logic in the main class. And I encourage you to use these tools, whether it's renaming, whether it's extracting methods, those kinds of things, to make that process easier. Nice. Okay, here's Project 3. Okay. So, yeah, I know that many of you are still finishing up Project 1, and that some of you have just now broken ground on Project 2, and not talking about Project 3. Well, I'm doing this to give you an idea of what's coming next. So anyway, Project 3 extends the appointment book project by adding the ability to pretty print it. I want you to learn about Java's capabilities for sorting objects and for working with dates. Because right now, everything we've been working with are just strings, right? Yeah, you have your appointment book and your appointment and stuff, but now it's time to leverage some of the facilities for doing more interesting stuff with your objects. So, oh no, it's still zone date time? That's wrong. It should be local date time. I apologize. I will fix that. Okay, so if you look at the appointment class, I'll bring this back up again here. So then, some of you may have noticed that if you look at the inherited, the class that appointment inherits from, the abstract appointment, it has these methods begin time and local time that are just return null right now. Oops, don't put it in the right place. And for projects 1 and 2, that was fine. Well, for project 3, you're going to use these. And local date time is a standard Java class that represents, well, a time, a date and a time. And so now, instead of just representing dates and times as strings, you're going to represent them as these local date time objects. So I want you to override get begin date time and get end time to return those values for the appointment. And I want you to modify your implementation of get begin time string, get end time string to format the begin time and end time effectively using something called format style.short. And all of this is explained in detail in the working with dates and times, or dates and text formatting lecture. Because as we evolve our objects, we're going to start using more interesting types for representing dates and times. So you're going to do that. Additionally, you're going to implement the ability to sort appointments chronologically by their begin time. Well, you're going to implement a sorting algorithm. Here's what the sorting algorithm is. First, you're going to sort by the begin time of the appointment. And if you have 2 appointments that begin at the same time, then you're going to sort them chronologically by their end time. Now, as you'll learn about, the local date time has the ability to sort. That object has the ability to sort. So really, your appointment object will delegate to the local date time objects to do the sorting. Now, if you have 2 appointments that begin at the same time and end at the same time, then and have the same description, then those are considered equal. Otherwise, you should use this algorithm for determining the order. Again, sort first by begin time, then by end time, then by description. I highly encourage you to have your appointment class implement the comparable interface, and you'll learn about comparable in the collections API lecture. What comparable says is like I can compare myself to some other object. You may recall, like on the first day, we discovered that string implements comparable because it knows how to compare itself to another class, another string. So there's some new capabilities of your appointment object that you'll be adding in Project 3. And then you'll also be adding a new type of appointment book dumper. Now, your text dumper is an appointment book dumper. Appointment book dumper is just an interface that takes an appointment book and dumps it to some destination. Well, in addition to dumping it to a text file, now you'll dump it to something called a pretty printer. And what a pretty printer does is it formats contents of an appointment book in a way that looks nice to a human. So your text dumper is all about generating a text format that is readable by a computer, by the text parser object. Well, now you have a one-way dumping, which is then dumped to a format that looks nice to a human. And this gives you an opportunity to use the datetime formatter class to make your dates look nice. Additionally, your pretty printer should include the duration of each appointment. So this is giving you an opportunity to work with a text formatting in Java. So these three new requirements of the code are meant to give you experience working with these new APIs that are described in those lectures. The functionality of the appointment book application is driven by a main class. Now it's going to be called Project 3, which builds upon the functionality of the previous projects and adds the ability to pretty print the appointment book. Oh, and by the way, in the pretty format, it should, you know what? I guess it doesn't say this, but the idea is that when the appointments are pretty formatted, they should be sorted. Oh, I guess I don't call that out. I'm really surprised. Maybe it's in a footnote or something. Huh, sorry about that. I guess I should be more clear. That when the pretty format that that appointment should be sorted. Anyway, here's the command line for the Project 3 main. It has options and arguments. The arguments are what they were last time. You have the owner followed by the description, followed by the begin date and time for the appointment, and the end date and time of the appointment. Note that the format of the date and time on the command line has changed. In Project 3, we're not dealing with 24-hour time anymore. We now have an AM/PM marker. So now you've got 3 command line arguments for the date and time instead of 2. And I do this on purpose, right? I mean, this gives you an opportunity to figure out, hey, how do I take that code that's been working for 2 projects and now make it handle a new structure for the date and time. So it has those arguments, and it has a new option, -pretty. And so this specifies where a pretty version of the appointment should be output to. So you can give it the name of a file, and so then you'll write the pretty version of the appointment to that file. And if the name of file is dash, and so if you say -pretty dash, then you should write it to standard out instead of a file. Otherwise, the -text file, the -print, and the -readme all have the same semantics as they have for the last 2 projects. Note that we should pretty print the appointment book after the new appointment has been added, right? Because every time you run your program, you're still going to add appointment to the appointment book. Now you have the ability to pretty print it in addition to write it to a text file. That question? Yeah.
What if you have the same file name as well?
Good question. I will not test your code with the same file for -pretty and -text file. So you can behave, you can handle that. You can say, oh, that's an error. You can have some weird behavior. I'm not going to test that. But that's a great question. Yep, that's not something I'm going to evaluate. Assess. Okay. And again, error handling. So if your command line is missing, or if you have extraneous command line arguments, format the date time is correct, is incorrect, or if the appointment's end time is before its begin time. Forget about time zones in this. We will, but just say, hey, want to make sure that the appointment's end time is always after begin time. And that's it. Nope, they won't be in double quotes. Again, the date and time is now 3 program arguments instead of 2. Yep, no, good question. It's kind of things that I'm, yeah, that I recommend that you ask about just for clarity. Okay, awesome. That is due July 30th. So you've got 2 weeks and 2 days to do that. So again, stuff is kind of coming here, fast and furious. And so I recommend that you finish up Project 1 quickly and then jump right into Project 2 to get that going, knowing that Project 3 is coming. Next week we'll talk about Project 4. That's all I had for tonight. Anything else people want to discuss? Excellent. Okay, sorry, yeah. Yeah.
There's a survey.
Oh yeah, the survey, yeah. Yep. Yes, the survey is for, it counts as a quiz break. Yep, so please do it. Yep, question. Excellent. Hey, thanks everybody. On Wednesday we have pairing. Again, you can be here in the classroom or you can be remote, but do participate because that informs what your reflection will be. Have a great couple days, everybody. I'll see you on Wednesday.